Hi, this is Vinay, and in this ICP, we are going to uh, show the sentimental analysis by using the deep learning classifier. So, first thing in the first step, we are going to import the libraries. So here we are using importing the pandas as PDA, and from NLTK we are importing the sentence tokenize and the word tokenize. Then we are downloading the popular keywords. So once we run the step one, we can see that uh, we are able to download the collection popular. Next step is to read the data. So here basically we are reading the data from the GitHub, where the it is having a raw data, and from there we are directly reading the data, which is a CSV format. So here by using the pandas dot read CSV, we are converting that data into the list, and we are printing it in the data underscore CSV. So once we print here, we can see that we have 4 columns: ID, label, and tweet, and there are 31,963 of tweets, 962 tweets. Next is that we are trying to read only 100 tweets for this ICP. So what we have done is that we have initialized a new list where we are reading by using the panda functions, by using the panda library, and by using the series function. We are trying to read the count up to 100 tweets, and then we are converting it to the string, and we are printing the length of the list, and then the type of the list, and the list itself. So once if we run this, we can see that the length of the data is 5599, and the type is str, and this is the tweet data. So we can see 100 tweets here. Next, we are splitting the data. So here splitting specifically we are talking about sentence tokenize and the word tokenize. So sentence tokenize, what will do is that the data is split into the sentences, and the word tokenize, it will split the data into words. Here we are using the two functions, sent underscore tokenize and word underscore tokenize, in order to obtain the result. So here we are displaying its length and the words. So once we run this, we can see that first thing is that it is split into sentences, then it is split into the words. Next we are trying to import the frequency distribution from the NLTK probability. So here we are trying to find the most common words by using the function most underscore common. We are displaying the 10 most common words. Here we can see that ash is used for the 94 times. So in this manner, it will display the output. Then we are trying to plot a graph, for the most common used words. So here if we see that ash, we have seen that it is used for the 89. So here we are plotting a graph for this. Then the step is to clean the words. So here cleaning is nothing but, we are trying to only consider the alphabets and ignore all the numerics or the characters. So for this, first we are initializing the clean word list. Then we are reading. Then we are using the for loop to read the data. Then we are checking by using the is alpha function. So it will basically check for the characters which are the alphabet letters, that is from A to Z. Then we are displaying the keywords and its the clean words and its length. After that, what we have done, we are trying to delete the repeated words, and we are trying to store them in the unrepeated words. So for this, first we are whatever the clean words that we have obtained, we are running in a loop. Then we are checking it whether if it's present or not. If it's present, the loop will not run. The values will not be appended. Only the values which are unrepeated, that will be appended. We are printing the length, and then we are displaying the words. We have 410 of words. Then what we are trying here in this step, we are trying to show the stop words from the English language, and then we are trying to filter the remove the filter the stop words from the words that which are unrepeated. So here we are using the no underscore stop underscore words as a list, and we are trying to filter the data basically. So once we run this, you can see that only 337 of no stop words are used. Then we are trying to plot a graph for the no stop words. Since we have already cleared the data, even if you plot the graph, it because since the list is of not repeated words, every word is used only once, and the graph is also same. Next step in this sentimental analysis is the stemming of the clean words. Stemming is basically cutting the word. So here we are using the Porter stemmer, and for the clean words we are trying to do the stem. So for that we are importing the Porter stemmer from the nltk.stem, and we are displaying the words, stem words. The next step in the sentimental analysis is the lemmatization of the clean words. So for this, we are importing the word net lemmatizer from the NLTK. Then we are performing we are running the loop for the no stop words, and we are displaying the. Here we can see that there are 337 of words. Lemmatization basically gives a proper meaning, whereas the stemming might not give the proper meaning. So lemmatization has a more advantage. Next step is the POS tagging. So here it's nothing but we are tagging the parts of speech for the each word that is obtained. Next, we are importing all the required libraries for performing the deep learning classifier using the Keras. So here, these are all the libraries that we are going to import. So here we are from Keras, we are importing models. From Keras, we are importing layers. We are importing the tweet tokenizers from an LTK tokenizer. From an LTK stem, we are importing the word net lemmatizer, and we are importing some of the models as well. So once if we check this, these are implement, and the next step is nothing but the splitting the data into 100 tweets. Basically in this ICP we are going to perform the sentimental analysis by using the deep learning model of a sequential model, and here we are basically considering only 100 tweets. So first we are checking if there are null values. Is null function will check if there are any null values or not. Then we are passing only from the data underscore CSV, we are considering only 100 tweets, and we are passing it to the data underscore 100, and we are trying to print the sheet. After that, here by using here we are using the fill NA. Fill NA, it's a function that will check for the NaN keywords, and it will replace them. So here in this step, we are passing the data into data underscore new for the 100 tweets. Then we are basically concatenating all the lemma words into a single string, and we are printing the data. Next step is the key step where we are building the data frame. So here what we are doing is that in data underscore new, we are building the two columns, tweet and the label, and we are displaying the shape. So here we can see that it has tweets are 100 and labels are 2. Next, we are plotting the graph for the data frame. So here we are using this variable group underscore df by using the data underscore new data frame with the label tweet. We are grouping it via label, and we are displaying it as a graph, as a bar graph by using the count. So here basically it shows how many of the negative responses here. So here we can see 91 with the negative responses and 9 with the positive responses. Next is just we are trying to build an instance to show that what exactly the data is. So here we have taken only one tweet and we have printed it as an instance. The next step is a key step where we are tokenizing of the data frame. Basically, because we have a bulk of data, we should, in order to get identified by the machine, we need to tokenize the data. Tokenization is nothing but the splitting of the data. So here by using the tokenizer function, which we are importing from keras.preprocessing.text, we are using the two functions, fit underscore on underscore text and text underscore to underscore matrix, where fit underscore on underscore text, we are basically assigning the indexes to the text, whereas by using the text underscore to underscore matrix, we are converting it into the matrices, converting the data into the matrices, and we are displaying the data. Next step here, we are encoding the data. For encoding, we are importing the label encoder from sklearn.preprocessing, and we are also importing the train test split function from the sklearn.model selection. So here we are encoding the data, and we are storing the data in Y, and we are printing the output. So this is the data that we have obtained. Now the main step of this is of the deep learning is that splitting the data into train or test. So here what we are doing is that we are using the function train underscore test underscore split, with where by using this function we can split the data into random train and test subsets. So here we have splitted, and we have printing it. So here we can see that we have got only 90 because test underscore size we are trying to remove uh, 0.1 of the data. That means, I mean, here we have 100 words, and we are trying to split and trying to consider only 90 of the words. So, and random state we are giving it as 50. So if you run this, we got x underscore train dot shape is 90 and 10,000, and x underscore test dot shape is 10 comma 10,000. Next, this is the crucial step in the deep learning, where I mean it differentiates from the machine learning and the deep learning, where the layers are built in the deep learning. So here we are building the layers. So for this, we are keeping the shape as 64, and activation here we are using two activations, relu and the softmax. So basically these two activation functions, relu is for the rectify linear activation function, where it provides the state of art results, and it's computational very efficient at the same time. And whereas the softmax, it is a mathematical function that will convert the vector of numbers into a vector of probabilities. So basically it selects the neuron with the high probability by using this activation function as softmax, and we are displaying the output. So here basically we are using base underscore model as a variable, and we are using the sequential model for this. So once we run this, the layers are built here. We can see the layer type, which is the name, the output shape 64, 32, 16, 2, and the params. So they are total parameters of 642, 706, trainable and the non-trainable. Next step is the last step, where we are training the model and finding the accuracy. So here we are using the two functions, compile and fit. So in this, we are compiling the data and then fitting the data. That means the training the model. Here we have used epochs. So epochs is nothing but the number of times the learning algorithm will work. I mean, how many times it should learn, we are mentioning it. And batch size, we have given it as 32. Validation data, we have given X test and the Y test that we have used above, and the verbals we have given it as 0. And then we are evaluating the accuracy of this model. So once we run this, we can see that the accuracy of this model is 90%. So that's the end of this. Thank you.